Hadirin dimohon untuk mengambil tempat duduk dengan memenuhkan ruangan hadapan auditorium ini. Pengumuman kedua, para hadirin dimohon untuk memastikan telefon bimbit berada dalam keadaan mod senyap sepanjang majlis ini berlangsung. Pengumuman ketiga, para hadirin dimohon untuk berdiri semasa pengacara mengumumkan ketibaan tetamu kehormat. Hadirin mohon kerjasama untuk memenuhkan ruangan hadapan auditorium. Terima kasih. Mohon kerjasama hadirin untuk memenuhkan ruangan hadapan auditorium ini kerana majlis akan bermula sebentar lagi. Terima kasih. Hadirin mohon kerjasama untuk memenuhkan ruangan hadapan kerana majlis akan bermula sebentar lagi. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Di sini terdapat beberapa pengumuman penting untuk perhatian para hadirin. Pengumuman pertama, hadirin dijemput untuk mengambil tempat duduk dengan memenuhkan ruangan hadapan auditorium ini. Pengumuman kedua, para hadirin dimohon untuk memastikan telefon bimbit berada dalam keadaan mod senyap sepanjang majlis ini langsung. Pengumuman ketiga, para hadirin dimohon untuk berdiri semasa pengacara mengumumkan ketibaan tetamu kehormat. Sekian, terima kasih. Mengumumkan ketibaan yang hormat Datuk Profesor Dr. Muhammad Roslan Sulaiman, Naib Chancellor Universiti Putra Malaysia, dengan diiringi Yang berbahagia Profesor Insinyur Dr. Muhammad Hairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan, bersama timbalan-timbalan Naib Chancellor, pihak pengurusan UPM dan pihak pengurusan Fakulti Kejuruteraan. Nyanyian lagu Negaraku dan Putra Gemang.
Maju bertakwa menunjang pribadi, berpadu tenaga mencapai kejayaan, sehati sejiwa berhebat Universiti Putra Malaysia, pembina wawasan gemilang. Universiti Putra Malaysia, membentuk siswa cemerlang. Semarak namamu di sinar zaman, semerbak namamu di suara sanjungan. Penyumbang bakti anak bangsa, pewaris sejati negara tercinta. Damai insan berbaik kota, tersemat citramu semerbak negara. Di darjat bangsa, di daulat negara, tersurat jasamu menjana kemajuan.
Hadirin persilakan duduk. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Yang hormat Datuk Profesor Dr. Muhammad Roslan Sulaiman, Naib Chancellor Universiti Putra Malaysia. Yang berbahagia Profesor Insinyur Dr. Muhammad Hairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan yang akan menyampaikan syarahan inaugural pada hari ini. Yang berusaha Encik Selvam Cinapan, Pengarah Urusan NR Malaysia, Timbalan-Timbalan Naib Chancellor Universiti Putra Malaysia, Pegawai-pegawai kanan Universiti Putra Malaysia, Ahli Pengurusan Fakulti, tetamu-tetamu jemputan, rakan industri, para staf dan pelajar serta hadirin yang dikasihi sekalian. Selamat datang diucapkan ke majlis syarahan inaugural yang berbahagia Profesor Insinyur Dr. Hairul Anwar Muhammad Arifin dan sesi perasmian UPM NI Embedded System Engineering Laboratory. Untuk maklumat semua, syarahan inaugural ini dilaksanakan secara hibrid yang dipancarkan secara langsung melalui Facebook UPM dan Facebook Fakulti Kejuruteraan. Penonton yang menyertai majlis ini secara atas talian dialu-alukan untuk menekan butang like dan share halaman Facebook tersebut. Penonton secara atas talian dimohon untuk mengisi kehadiran yang pautannya dikongsikan di ruangan komen, manakala para hadirin yang hadir secara fizikal dimohon untuk mengimbas kod QR di luar auditorium untuk sijil penyertaan dan mata SPD untuk staf UPM. Bagi memberkati majlis pada pagi ini, majlis dengan segala hormatnya menjemput Encik Muhammad Saiful Azwar Muhammad Isa untuk memimpin bacaan doa. Dipersilakan.
Assalamualaikum warahmatullahi wabarakatuh. Ila syarafin Nabil Mustafa Rasulillah sallallahu alaihi wasallam wa alihi wa zuriyati ajma'in. Syai'ulillahi lahumul Fatihah. A'udzubillahi samil alim minasy syaithanir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Arrahmanir rahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Wa qala rabbukum ud'uni astajib lakum. Da'unaka ya Allah fastajib lahum du'ana ya sami'ad du'a. A'udzubillahi samil alim minasy syaithanir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Hamdan hamidin, hamdan syakirin, hamdan yuafi ni'amahu wa yudafi niqamahu wa yukafi mazidah. Ya Allah, Ya Rabbana, lakal hamdu kama yanbaghi li jalali wajhikal karim wa azimi sultanik. Radina billahi rabba wa bil islami dina wa bi Muhammadin sallallahu alaihi wasallam nabiyya wa rasula. La ilaha illa anta subhanaka inna kunna minaz zalimin. Allahumma salli ala sayyidina Muhammadin tibbil qulubi wa dawaiha wa afiyatil abdan wa shifaiha wa nuril absari wa diyaiha wa ala alihi wa sahbihi wa barik wa sallim. Allahumma salli salatan kamilatan wa sallim salaman taman ala sayyidina Muhammadin alladhi tanhallu bihi al-uqd wa tanfariju bihi al-kurab wa tuqda bihi al-hawaij wa tanalu bihi al-raghaib wa husnul khatim wa istasqal ghamam biwajhil karim ala alihi wa sahbihi fi kulli lamhatin wa nafasin bi'adadi kulli ma'lumin lak. Allahumma anta khalaqtana wa nahnu ibaduka wa nahnu ala ahdika wa wa'adika mastata'na. Na'udzu bika min syarri ma sana'na nabu'u laka bi ni'matika 'alaina wa nabu'u laka bi dhunubina faghfir lana fa innahu la yaghfiru dzunuba illa anta. Ya Allah Al-Majid Ar-Rahman Ar-Rahim Asyakur, sesungguhnya kami memanjatkan kesyukuran di atas segala nikmat dan rahmat yang telah Engkau kurniakan kepada kami, kedua ibu bapa kami, ahli keluarga kami, sahabat handai kami, guru-guru kami, serta seluruh warga Universiti Putra Malaysia. Ya Allah Al-Mu'izz, Engkau berikan kami kekhusyukan di majlis inaugural yang berbahagia Profesor IR Dr. Muhammad Khairul Anwar Muhammad Arifin pada hari ini. Mudah-mudahan kami tergolong dalam kumpulan yang Engkau muliakan, serta Engkau muliakan juga mereka semua yang terlibat bagi menjayakan majlis ini. Ya Allah Al-Fattah Al-Wadud, kami mohon padamu wahai Allah, semoga majlis inaugural yang berbahagia Profesor IR Dr. Khairul Anwar Muhammad Arifin ini diberikan kelancaran, dimudahkan segala urusan dan di akhirnya beroleh kejayaan. Ya Allah Al-Basit Al-Khaliq, Kau bukan seluas-luasnya pintu-pintu ilmu agar dapat kami memanfaatkan dalam pekerjaan kami sebagai sebahagian usaha kami demi meningkatkan kecemerlang diri serta Universiti Putra Malaysia. Ya Allah Al-Muqid, Kau bukakanlah jalan kejayaan serta kurniakan kekuatan kepada kami dan generasi-generasi selepas kami untuk kami menjunjung serta mencintai ilmu, wahai Allah. Ya Allah Al-Quddus, wahai Allah yang mengarahkan hati, arahkanlah hati-hati kami untuk taat kepadamu. Kau sucikanlah dan peliharalah ia. Semoga sepanjang ibadah pekerjaan kami di Universiti Putra Malaysia yang kami cintai, serta hidup seharian kami bersama keluarga, sahabat handai dan guru-guru kami, dapat menempatkan kami di kalangan hamba yang Kau ridai. Ya Dzal Jalali wal Ikram, tambahkanlah kepada kami kecintaan kepada segala kebaikan dan benci kepada kemaksiatan. Jadikan kami, guru-guru kami dan pemimpin-pemimpin kami istiqamah dalam menabur khidmat bakti untuk memartabatkan agama serta membangunkan umat, bangsa dan masyarakat. Wahai Allah, peliharalah negara kami dari dan huru-hara dan segala bentuk ancaman. Peliharalah perpaduan kami rakyat Malaysia supaya hidup dalam keadaan yang damai, selamat, sejahtera dan taat setia kepada negara. Allahumma ja'al jam'ana hadza jam'an marhuma wa tafarruqana min ba'dihi tafarruqan ma'suma wa la taj'alillahumma fina wa la ma'ana wa la ma yatba'una syaqiyyan wa la mahruma wa la matruda. Allahumma zidna wa la tanqusna wa a'tina wa la tahrimna wa akrimna wa la tuhina wa la tu'thir 'alaina warḍ 'anna wa'fu 'anna ya Allah ya Karim bi rahmatika ya arhamar rahimin. Allahumma rabbana hab lana min azwajina wa dhurriyyatina qurrata a'yun waj'alna lil muttaqina imama. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana la tuzigh qulubana ba'da idh hadaytana wa hab lana min ladunka rahmah innaka antal wahhab. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzaban nar. Bismillahirrahmanirrahim. La yadur ma'a ismihi syai'un fil ardi wa la fis samai wa huwas samiul alim. Bismillahirrahmanirrahim. La yadur ma'a ismihi syai'un fil ardi wa la fis samai wa huwas samiul alim. Bismillahirrahmanirrahim. La yadur ma'a ismihi syai'un fil ardi wa la fis samai wa huwas samiul alim. Wa sallallahu ala sayyidina Muhammadin wa ala alihi wa sahbihi ajma'in. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin.
Amin, amin ya rabbal alamin. Terima kasih di atas pimpinan bacaan doa sebentar tadi. Seterusnya, majlis dengan segala hormatnya menjemput Datuk Profesor yang hormat Datuk Profesor Dr. Muhammad Roslan Sulaiman, Naib Chancellor Universiti Putra Malaysia untuk mempengerusikan majlis syarahan inaugural ini, dan seterusnya menjemput Yang berbahagia, Profesor Insinyur Dr. Muhammad Khairul Anwar Muhammad Arifin untuk menyampaikan syarahan inaugural beliau. Majlis dengan segala hormatnya mempersilakan.
Terima kasih saudari pengacara majlis. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Yang berbahagia Profesor Insinyur Dr. Muhammad Khairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan, Timbalan-Timbalan Naib Chancellor Universiti Putra Malaysia, Pegawai-Pegawai Kanan Universiti Putra Malaysia, ahli pengurusan Fakulti Kejuruteraan, tetamu-tetamu jemputan, rakan industri, para staf dan pelajar, sidang penonton yang saya hormati sekalian. Alhamdulillah, bersama kita merafakkan kesyukuran kita kepada Allah SWT kerana dengan limpah kurnianya kita masih lagi diberi peluang untuk bersama-sama bagi meneruskan usaha memartabatkan kesejahteraan ilmu pada pagi Jumaat yang penuh barakah ini. InsyaAllah sebentar lagi kita akan mendengar syarahan inaugural ataupun perkongsian yang akan diberikan oleh yang berbahagia Profesor Khairul. Sebelum itu, izinkan saya untuk membacakan sedikit latar belakang berkaitan dengan Prof. Insinyur Dr. Muhammad Khairul Anwar untuk kita sama-sama hayatilah orang yang akan naik pentas sebentar lagi, insyaAllah. Muhammad Khairul Anwar bin Muhammad Arifin dilahirkan pada hari Isnin, siap hari 6 Mei 1974 di Besuk, Terengganu. Besuk Terengganu. Beliau merupakan anak ke-6 daripada 7 beradik kepada pasangan Muhammad Arifin bin Said dan juga Halimah binti Cik Had. Dr. Muhammad Khairul Anwar telah mendapat pendidikan awal di Sekolah Kebangsaan Tanah Merah, Jerteh, Terengganu. Seterusnya beliau telah menyambung persekolahan beliau di Sekolah Menengah Agama Marang Terengganu dari tingkatan 1 hingga tingkatan 4 dan seterusnya Sekolah Menengah Agama Ittifaqiyah Jerteh Terengganu dari tingkatan 4 hingga tingkatan 5. Dia lepasan sekolah agama. InsyaAllah ni boleh jadi pengarah pusat Islam. Selepas zaman persekolahan, beliau meneruskan pengajian diploma di Sekolah Agama Sultan Zainal Abidin, Huza, Gom Badak, Kuala Terengganu dalam bidang teknologi perindustrian pada tahun 1992 hingga 1996. Setelah menamatkan pengajian di peringkat diploma, beliau meneruskan pengajian di peringkat sarjana muda Kejuruteraan Sistem Pembuatan di Universiti Northumbria di Newcastle, United Kingdom. Setelah tamat pengajian sarjana muda beliau telah memulakan pekerjaan di Pewaja Steel Kemaman Terengganu. Hadirin hadirat yang saya hormati sekalian, kerjaya akademik Dr. Muhammad Khairul Anwar bermula pada tahun 1999, iaitu setelah dilantik sebagai tutor di Universiti Putra Malaysia, Kuala Terengganu. Kerjaya ini telah memberi atau membuka peluang kepada beliau untuk melanjutkan pelajaran ke tingkat sarjana di UPM pada tahun 2000. Setelah menerima ijazah sarjana kejuruteraan sistem pembuatan, beliau telah menyambung pengajian beliau di peringkat PhD di University of Sheffield, United Kingdom selama 4 tahun, itu dari 2002 hingga 2006, dan beliau telah kembali ke tanah air pada Jun 2006. Sekembali beliau ke UPM, beliau telah dilantik sebagai pensyarah di Jabatan Kejuruteraan Mechanical dan Pembuatan Fakulti Kejuruteraan. Beliau merupakan peneras pembangunan di jabatan pada tahun 2008 sehingga 2012. Seterusnya, beliau telah dilantik sebagai Ketua Jabatan Kejuruteraan Mechanical dan Pembuatan bermula 2012 sehingga 2015. Terkini, beliau merupakan dekan Fakulti Kejuruteraan bermula pada 15 Julai tahun lepas. Hari ini hadirat sekalian, Profesor Dr. Muhammad Khairul Anwar juga merupakan seorang jurutera profesional yang berdaftar di bawah lembaga ataupun Board of Engineers Malaysia dan berbekalkan pengalaman lebih daripada 16 tahun dalam bidang pengajaran, penyelidikan, kepakaran penyelidikan termasuklah kejuruteraan pembuatan dan pengoptimuman. Sehingga hari ini, beliau telah menerbitkan lebih 150 artikel jurnal dan menerbitkan 2 buah buku, 6 bab dalam buku di peringkat antarabangsa selain menjadi penerima pelbagai anugerah di dalam dan di luar negara. Beliau juga merupakan Presiden Professional Association in Modern Manufacturing Technologies, LASI Romania, Asia Branch. Beliau juga berkhidmat sebagai panel penilai untuk Majlis Akreditasi Kejuruteraan Malaysia dan Majlis Akreditasi Teknologi Kejuruteraan. Prof. Muhammad Khairul Anwar juga aktif dalam penglibatan dengan pihak industri, antaranya Proton, CTRM, PMC, Steelcase, ES Chuan dan Press Maju. Beliau juga merupakan pegawai utama yang dirujuk kerjasama di antara UPM dan Steelcase. Di peringkat antarabangsa, Khairul telah dijemput sebagai pembentang dan penceramah lebih daripada 20 persidangan di seluruh dunia, masuk Arab Saudi, Korea, Indonesia, Romania dan Jepun. Hadirin hadirat sekalian, secara kolektif, Prof. Khairul telah menerima grant penyelidikan bernilai kira-kira 2 juta ringgit dari dalam dan luar negara dan telah menjalankan konsultasi bernilai hampir 200,000 dalam bidang perundingan profesional. Dalam bidang inovasi, beliau telah memfailkan hampir 6 paten dan kini beliau sedang dalam proses untuk mengkomersialkan tahap utama beliau iaitu Post Conditioning Injection Molding Machine for Glass Fill Nylon, Polyamide 6, Polyamide 6, dan Filament Nozzle Extruder for PLA Materials. Saya tak tahu apa itu, minta maaf. Jadi merentasi lebih 20 tahun berjaya, Prof. Khairul Anwar telah menerima berbagai pengiktirafan dan anugerah, antaranya PRPI 2007, PRPI 2009 dan pelbagai anugerah dan juga pengiktirafan di peringkat dalam dan juga luar negara. Jadi tanpa membuang masa, hadirin dan hadirat yang saya hormati sekalian, sekarang mari kita mendengar syarahan inaugural oleh Profesor Insinyur Dr. Muhammad Khairul Anwar Ma'arifin bertajuk 3D Printing, The Power of Desktop Manufacturing. Saya dengan segala hormatnya menjemput Prof. Khairul untuk memberikan syarahan. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Dipersilakan.
Terima kasih kepada Puan Pengacara Majlis yang dan juga kepada pembaca doa kita, Yang Tuan Saiful Azwar Mak Isa, kerana telah membacakan doa yang penuh dengan berkat insya-Allah pada pagi hari yang mulia ini. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Salam sejahtera, salam Jumaat, penghulu segala hari. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Qala rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Amma ba'd. Yang hormat Datuk Profesor Dr. Muhammad Roslan bin Sulaiman, Naib Chancellor Universiti Putra Malaysia, Yang Berusaha Encik Selval Cinapan, Pengurus Besar NI Penang Malaysia, Timbalan-timbalan Naib Chancellor, Pegawai-pegawai kanan Universiti Putra Malaysia, Barisan Pengurus Kejuruteraan UPM, Pegawai-pegawai Universiti Putra Malaysia, Sidang Okey, minta maaf ada gangguan sikit. Dan juga keluarga saya yang tercipta, terutamanya kepada isteri saya, Puan Isnarita Zakaria. So, saya mohon kepada Sekretariat untuk bagi hadiah kepada isteri saya kerana menyokong saya selama ini, insyaAllah. Beliau melupakan tulang saya lah selama ini dalam hasil kerjaya. Berjaya saya hari ini adalah daripada kritisasi beliau dan juga sokongan beliau. Alhamdulillah, terima kasih wahai isteri tercinta. Seterusnya, sedikit kejutan, anak saya Muhammad Arif Zikri tidak dapat bersama dengan kita hari ini. Beliau di UTM sekarang kerana mengikuti kurs diploma kejuruteraan elektronik. Dan salah satu lagi anak saya, Aisyah Yasmin Husna, merupakan hari jadi beliau ataupun hari lahir beliau pada hari ini. So dengan itu dijemput kepada SU untuk bagi ceremata sebagai sambutan hari lahir beliau. Rupanya hari kemas ditunda majlis saya ini daripada 18 kepada 9 Disember. Alhamdulillah, selamat hari lahir kepada Yasmin Husna. Okey, hadirin hadirat sekalian, sebelum saya memulakan syarahan inaugural saya ini, saya mohon kepada yang beragama Islam untuk sama-sama kita membaca Ummul Kitab Al-Fatihah, dan kepada yang bukan beragama Islam dimohon untuk bertafakur sejenak semasa kita membaca Ummul Kitab Al-Fatihah. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Ar-Rahmanirrahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Amin amin ya rabbal alamin. Terima kasih semua. Pahala-pahala ni kita sedekahkan kepada arwah ibu saya yang telah meninggalkan kita semenjak tahun 2017, dan juga kepada kawan-kawan, sanak saudara, rakan-rakan kita semua, insya-Allah dipanjangkan pahala tadi kepada mereka yang telah pergi meninggalkan kita. Hadirin hadirat sekalian, izinkan saya memulakan syarahan saya ini dalam bahasa Inggeris. So, Datuk WC dah cakap tadi 45 minit je. Yang dibagi masa saya. Okay, praise to Allah Subhanahu Wa Taala, with His blessing and His guidance, we are gathered here today, either face to face or online, to listen to this history become history later on. Inaugural lecture series 273. Before I start, I would like to thank for all of you participate in this lecture, and I know that your time is very precious. Thank you very much. Thank you very much, and thank you very much. And I hope that when you listen to this lecture, you can get something, grab back home, and then if you got questions, please keep it for yourself, and then later on you can email me if you got any further discussion to do and so on. Okay? The title for today's lecture, inaugural, we call it 3D printing, the power of desktop manufacturing. So I hope at the end of the lecture, everybody know why I said the power of desktop manufacturing. Let me try my slide first. Okay, this lecture will consist through, I will go throughout this title. I'm going to go with the history and also family of myself, even though the Vice Chancellor already explained a little bit, a bit about myself, but I will the history of myself together with the photo and so on. And then I will go further with acknowledgement, some people that are already around me, and then the people eventually make me success, the one that I'm really nowadays. And I will go to the main of the lecture, which I'll start with introduction, material decomposition, printing process, printer part, machining, and so I will end with the conclusion. So this is me, like our Vice Chancellor said, this is actually in Ittifaqiyah Islamic School. So my base actually during my SPM is on art, not in science. So just imagine that I convert from art to science. It's very difficult for me actually. So can you guess which one is me? Middle, not correct. So me is which one? Okay? So the one from the right, from your view. So I'm actually come from furnished family. And boarding school actually at Perkaya, Pertubuhan Kebajikan Anak Yatim Terengganu. Then I believe one of my colleagues here from the industry. So thank you very much for your support. And this is me during diploma of industry technology. Sweet 19 at that time. You can see now. I wearing the, what we call full coat during a workshop and so on that we wear to make sure that you go to the workshop and then you can use a machine to cut the materials and so on. And then you can see that I managed 7 semester dean's list. Alhamdulillah, every semester I got this list. So thank you very much for that. So semester 8, there is no dean's list because we already graduate on that semester. Otherwise, I still get this list. Okay, this is me during summertime in Northumbria or Newcastle, picking up strawberry to find extra money to travel to you. So you can see that my ass is like Prof. Tuah last time. Okay, this is the one we sent to newspaper during the Hari Raya celebration. And then one more time, can you guess where am I? Black with the cap. So that's me actually. So just imagine that how my face is changed. From younger become older, alhamdulillah. And this is me during convocation 26, and my supervisor is here, Professor Samsudin. Yeah. I got my master with, in research actually, Master of Science. And this is my conferment of PhD in 2008. Ministry University did it at KL. And this is me with Vice Chancellor during convocation 44. So proud of myself to be here together with the Vice Chancellor, also Deputy Chancellor. And this is me getting married in 1999, May 1999, inshallah. So I met my wife actually during study at UK. So we are together studying and managed to get second class upper. So I'm the best one in that class. So nobody gets second class upper at that moment. Yeah? So this is a celebration of the marriage. And we set up pink color, believe it or not. Pink color. So this is a celebration at my mother's house, and then the celebration at my in-law house. And this is me currently, have 2 children, 1 son and 1 daughter. Alhamdulillah, been blessed with 2 children. And this is our big family, and then you can see my brother in there. So, Encik Shukri, Mr. Shukri. So actually this photo is 2016, before my mother passed away in 2017. So that's all the memory that I have with my late mother actually for the photo. Okay, this is me. I'm active with the student and also sport. I managed to This is first car that we met actually with Professor Tuah there. You can see Tuah. That's why I said that Tuah had very long hair at that time. Okay. This is the first car that we managed to complete in 2008 and managed to compete at U10. And believe it, it's complete 3 o'clock in the morning, and then we send it 5 o'clock in the morning to U10. So that's how we work actually. Work very hard, but not smart at that time. Okay. And then this is me and Tuah. We went to Lita Datuk School in Pasir Salak for competition race, and then we managed to get second class. Not second class, number 2 actually. Okay. And then this is me with the team of table tennis representing UPM for SUKOM competition. So we managed to get maximum actually bronze medal. Bronze medal, number 3 lah, 3 and 4. That's a little bit background of myself, then what I did actually with the faculty. I'm not only work in silo, but we work together with students as well, and then we also embark with the student activity. Alhamdulillah. So with the support from the student, we are managed to get the car. Actually, now we are managed to get to international competition under Japan, Suzuka track. So this acknowledgement, please give a big clap to this committee member. So without we are not here today to see the inaugural lecture from me. So thank you very much for committee. Inshallah later on we are going to have a good meal after the ceremony. Okay, this is the person that I would like to show today. Unfortunately, I cannot find Professor Megat. Professor Megat is currently retired from UPNM. He is the one that actually allowed me to enter to UPM Sedang, because the Vice Chancellor said that I'm obviously starting my career with UPM Terengganu. At the moment, UPM Terengganu, there is no manufacturing system engineering. That's why I come and then see Professor Megat, said that I can be accepted at Department of Mechanical and Manufacturing Engineering at UPM Sedang. So he said that you are more welcome, and then we go together, met the late arwah Datuk Radin, and then the Dean also agreed. So that's why career, my path here, been here. So the next one is Professor Nafsia. She's the one that actually gave me the motivation to become a good leader, and then be supported as the head of department starting from 2012 until 2015. And Professor Nafsia as well did give me one PhD student as starter for me to develop my research career. And not to forget my Sifu, Professor Samsudin Sulaiman. Please give a big clap for him. He is the one that mentored me until I'm success today. Thank you very much, Professor, for your help. And currently, I am in depth with Professor Samsudin, and I am ready. Treat him as a father now. Thank you very much, Professor. And then in the group, actually, Advanced Manufacturing Research Group, we tried to convert the group become Advanced Manufacturing Research Center, but unluckily, it's not been accepted yet by TNCPI. So we try our hard to get TNCPI to recognize our Advanced Manufacturing Research Center. So those are the people that actually work together with me in the group. Dr. Faiza, Prof. Tuah is working together with me. We are in the same line, talking at the same language, actually, manufacturing system engineering. And then we have Dr. Tang, Dr. Idris, I.R. Razali, Dr. Asfanizam actually is my mentee now. Alhamdulillah, she's become the associate professor under my guidance. And then we have a newcomer, is Dr. Nurul Izzah. Apart from that, people who are not in this group actually work together with me as well. I would like to highlight the name here. Professor Faiza from Aerospace. Please, Professor Faiza. Professor Kamaru at the back. Always criticize me on the research as well, and also the management. So accept criticism, that's why you become a good manager. And then we have Professor Tariq here. He's not here. Professor Tariq. And we have another also, academician and so on that help me, but I cannot, do it one by one. So I'm going to go further. I managed to have this collaboration with industry, especially Dr. Azim there, as the director for ASEAN Pacific, the steel case industry. the industry that bring forward a lot of money and also effort to the university actually for bringing up our Think Space 2.0. Thank you very much, case. And then I have MPM. I think there is a representative from our MPM, Micro Precision Machine. So we work together in order to get international risk grant from Asian University Network under JICA and collaboration with the KU University. And this is PMC, the one that sponsored our campaign today. Please. InsyaAllah, thank you very much for the campaign. Kami golek. And then those three universities basically is my contact, very close contact to do work either in 3D printing and also become an external examiner for their program. So that's basically my relationship with industry, also with the university. So this is my PhD student. I'm proud of them now. Actually, all 23 PhD students have their higher post now. Some of them, like Dr. Zim, is to become a director for ASEAN Pacific. It's very big a job for him, actually. And then we have manager in the far north and so on. So just see their face now during their PhD study, very young. So I would like to highlight as well, my PhD, actually, 7% of them are international students. So I managed to get only 30% from local. I do not know why. Maybe I've been known internationally, but not locally. That's what happened to me, maybe. So we can see that I have Dr. Reza, Hamid Reza, Mojtaba Umali, and Dr. Uzir now with UNIMAP as a lecturer, a senior lecturer. And then I have Dr. Andi Al-Hafendi from Continental Penang. So he's a manager at Continental. So anything at the north, then I can contact him to do what collaboration and so on. And then I have Kuwait, and also Dr. Ahmad is working in the Saudi embassy in Australia. So anything with Saudi, normally I will contact him to get some connection and so on. And then I have Dr. Aidin with me. He managed to be a senior lecturer, and then I believe that he already in this hall. Yeah, Dr. Aidin there. Thank you very much for coming to UPM. And I have Dr. Salah, basically from Iran as well. And then this is my first student that transferred from Professor Nafsia to me. He graduated in the year of 2013. Dr. Yusuf currently is lecturer at Aceh University. I have others. Dr. Jabri is the one that is leading the company in Saudi now. And Dr. Aiman is the one that I'm going to show you the product that we produced together with him for today's lecture. And I have Dr. Lim, yeah, I already explained about him a lot because he had got a lot of connection with me. And Dr. Rosdi from Otta Precision is there over there. Thank you very much for coming for support me. And the newest one, actually, Dr. Zaleha Hamid. Are you here, Zaleha? Yeah, thank you for coming. So the last one that we went for convocation together, Convocation 46, Dr. Zaleha, from UKM. She is current lecturer at UKM. Okay, those are another names. I've been course forever. You can see that how many names there. It's almost around 40 students. So my target actually, when I become a retired man from UPM, I can get 50 PhD students as a main supervisor, inshallah, in the future. So without further ado, I'm going to continue with my lecture for today as the time goes by now. So I'm going to cover a little bit about the content. I'm going to go with machining, and after that we'll go with optimization, and finally we're going to go and see the component for the 3D printing. So this is the 3D printing that people have been talking about, and everyone already know already. 3D printer is one of the pillars at 1.0. It cannot go away because you can print and then you can use the product that you print straight away from the machine. It's like a bake. When you bake, then you can eat the cake. So it's just like that. So now it become a top 10 technology in the world. So even if you are looking at plastic, metals, ceramic, and so on, you can print using 3D printer. So you can see that why I say that power of the manufacturing, because the printer is being put on the desktop. So it's very small in size and then very convenient for the print. And then some of us actually know this as additive manufacturing because of the process involved in there. So I hope the animation is working. So you can see that this is comparison between machining and also 3D printer. So just a little bit inverse. So machining, normally we're gonna use a subtractive method. So you have to remove the material. At the same time, we're gonna waste energy, we're gonna waste the material, also we're gonna waste the human labor and so on. So by doing this machining, so you can see that from this animation, all the material is out from the block that we want to machine. So this is the machine at our lab. This is list. I'm going to show later on how the process has been done. And then this is additive manufacturing. So we start layer by layer, and then at the end you have your part. So it's very easy and simple to do. But even though it's simple, there is a lot of processes inside that, also the parameter that you have to control during the printing process. So this is me just to show that the printer that we have at the lab. So we call it Race 3D. So there is a voice for that, but purposely mute the voice, just so that this is the machine that we have at the lab. So anybody that is interested to print something, please come and see me, and then I can just print out whatever design they need, limited to the certain dimension and so on. So we're going to go later on with that. So this is basically how do we measure cutting force during machining. You can see that we have dynamometer. We bought it for 300,000 ringgit. And then I think it's well worth spending the money because we can get the mechanism of the cutting process. So this is the cutting process that our Vice Chancellor has been asking just now. I hope that he can understand what's happening in machining. So basically, it comes with this, we call it stock, cylinder stock, okay? This cylinder stock you have to put in the jar, then you clamp, okay? And then after that, you're gonna use this cutting tool. This is like special cutting tool that we developed together in the lab. So when you machine, we rotate this, and then the cutter will come, and then you can cut this according to the design that you have. So I hope that the video can capture that for this thing. So that's what happened, that we have to find out what happened during the machining. Even with our naked eyes, we cannot see the mechanism, what happened inside that. So the issue with the machining is that we have to remove the material. At the same time, we have to control the temperature during the machining. So this was done by Dr. Rosdi. Last time we managed to get a new cutter. We call it dual point cutting tools. And then still in the process of commercialization. So I need to see NCPI later on to make sure that this can be so-called commercialized. And this is the work that has been done with KU University, because at the time we do not have a 5-axis machine. So we try to get it next year, maybe, for 5-axis. So we call it composite fiber reinforced plastics. So we have a Kevlar, we so-called it make it sandwich with the aluminium, so that the thing around 10 mm. So it's very hard for us to machine, because during the machining we'll introduce vibration. So we have to control that vibration, and then the thickness of the web actually is very thin, about 1 mm. So if you make mistake, basically you're gonna throw away all your workpiece or your specimen. So this material actually can be used inside the aerospace component. So I forget to tell you that during my PhD, I actually developed a cutting tool path for the aerospace manufacturing component. So it's very high precision we have to do machine. So the reason why now I went into 3D printer, so you can see that this is 3D printing that we developed with Dr. Aiman. Managed to print a biodegradable material called it PMMA, which is suitable to put near the human body. So unfortunately, I do not have any more grant to do the research with the ethics and so on. So I just stopped with the machine, complete with the nodal, but it not been implemented yet for medical use. So I hope later on, maybe somebody can offer up mine and then would like to sponsor me or to give me a grant to continue this research. So the reason why, the first one is that less waste produced, because you know that we do it layer by layer. So I'm going to show you some sample here. So it's like sandwich. So you eat sandwich today, right? So it's going to be first layer, and then we print all the first layer, and then come again second layer. So you can capture. So come again second layer, and then the third layer. So this is the problem that we are facing with the 3D printer, because layer by layer, there is a possibility of defect between contact, first layer, second layer, and third layer. So that's very basic about 3D printer. Then I would like to highlight as well. So this is the one that I think everyone has read. This is the bone. Replica of the bone we can print using our machine. It's very nice and easy. If Faculty of Biomedics as well, then this we can print out of our oven. Yeah? And this is the one that nobody wants to see. This is Carl. All right? Oh, Datuk Vice Chancellor won this. Okay, I'll give it to her. This one actually, the machine capable of printing this, we call it porous bone. The reason why we printed this, actually you can put this inside your body. If you got accident and so on, can replace the damaged bone, and then it will eventually promote the growth of the cell bone. So that is our intention actually. But there is issue that might be a debate later on. So I'm not gonna go in that. Yeah? So in order to keep up with the time, I have a lot of slides until 75. Now it's 25. So I'm going to go in fast mode now. In optimization of the additive manufacturing, we have here the three. Yeah? The first one is material composition. Second one is part device, and the third one is optimization of the device setting. So in the nutshell, for the basic of understanding of 3D printer, basically it will consist three areas. In terms of technology, is sintering, melting, and stereolithography based on the resin. So by looking into this, actually, you can develop up to 8 different regions of the 3D printer. The first one based on the resin. Second one based on the material jetting. The one that we have in the lab is material jetting, so that you can get a very good surface finish. And one is binder jetting. This is based on the powder base. And the third one is material extrusion, the one that actually I'm embarked in, on the research has been done in. We call it short form FDM. And we have inkjet printing. This one basically is being used for biomedical to print tissue. And so some of them might be printing of the tablet that you eat. Can use this technology as well. And this is one, the old one that you can find, LOM, Laminated Object Manufacturing. And then directed energy deformations based on, so this is basically if you want to print a metal part. And also some of them will be used for printing the aerospace component part, like titanium and others. So this is the one that I saw in Northumbria University when I did my degree in the year of 1997. So this is why my passion actually come to this machine. How on the earth that this machine can produce very simple part using the CAD design. You know, at that time, 1997, you have to have the server and also workstation in order to use CAD. So it's very difficult. You have to have booked your time to go for the workshop and then design your own part and so on. After that, you can print using this machine. So what we did actually, with this machine, we can print like fan. This is caliper for your car when you brake. So you print this, and then this is cover for, we call it gearbox. And what we did actually with this, we have this pattern, and we put into sand casting. So we remove the pattern, afterward, we're going to put the aluminum or the steel to make sure that you can get your gearbox. So just imagine how important is manufacturing for you, for your life, in fact. Eh? So we have another method like sintering. This is basically based on the powder. And then we have another method called melting. So this is the one that actually Prof. Tuah just said just now. We can produce the peel using this technology. So you can mix or pre-mix inside that, and then you can produce the peel according to the what kind of ratio that you require. So we call it melting technology, and then it looks like injection molding. I'm working on that. I hope you can understand what is injection molding, by the way. Yeah? And then this is the one, actually, the best one for the surface finish. If you print using resin, definitely you're going to have a very good quality surface finish. And then the one that interested me and Dr. Aiman. I cannot see Dr. Aiman. Maybe he's waiting outside. So this is FDM. So what, eventually you're going to have the raw material of filaments. So this filament will be fed up into this liquefier chamber so that you can heat the filament, become liquid. Therefore, you can print after that. So might be someone interested in this. These are those parts that we can produce using this technique. Okay. This is metal. This is basically what you print and then you can use straight away. No need another second process and so on. So it's not prototype anymore. It can be used straight away in your application. And you can see this is the one that we print, actually the bones. And this is FDM. You can print all the sample. This one being printed by using the resin. So that's why we can get a very see-through product. So normally this one for aesthetic value. And now I'm going to move a little bit about the research that we've done. So as I said, we have condition, parameters, and also process that we have to make sure that we can have optimum parameters for that. First one is material itself. Second one is the part, like the nozzle diameter, and also liquefier shape, and also the process itself include the build orientation, layer thickness, infill pattern, and also infill feature. So in order to reduce the waste of time, basically we're going to use computer in order to check whether the optimum parameter can be achieved or not. So usually we're going to use CAD. Most of us in the lab using the SolidWorks or CATIA to do the design. And after that, we're going to use computer-aided engineering, like finite element analysis, to analyze the optimum parameter later on we're going to put in machine. So this is the work that has been done, been published in Q1 and Q2 journal, Alhamdulillah. So you can see different temperature gonna give you different result. And we have to control this temperature. That's why I said that I'm using the optimization method, like fuzzy logic, genetic algorithm, neural network, and so on, to make sure that we can get a very good surface quality when we finish. At the same time, also we are looking at the mechanical properties of that part that we produce. So, in a nutshell, if you have a low temperature, which is not according to temperature that the material is required, therefore you're going to have this low bonding between each layer and going to affect the surface finish, we call it. And normally we call it engineering RA value, the RA value. And next one, if you are excessively give the temperature up to 260, this one is basically for PLA. And then you're going to have a road width. It's not the road. We call it road width because it becomes bigger, expand during the process. So that you cannot get a very good surface finish again. So that's your intention. That's why parameters processing is very important. And this material, actually the work is done with Prof. Tariq, this one. We are looking at green composite material. So we add kanaf to PLA to make sure that green material can be sustained, you can plant and so on. And afterward, we made that become a filament, so the filament will go through the nozzle of the 3D printer. And then this is a test specimen. This one is basically for tensile test to make sure whether it complies with the standard or not. So this is the, I think this one is just go through our test, and fortunately we managed to print ankle foot orthosis by using this material. So as I said before, our purpose for developing this machine actually to print a biodegradable material. So it's based on the PMMA. So therefore we have to test the compression. So you want to compress the material so that you can know that what are the load possible for the material can take. So it's very important because we need to know the load. Otherwise, if you put this material inside somebody's hand or somebody's leg, and when they stand up, suddenly it will collapse down because there is no load on that. So that's the reason why we test this compression. And luckily, this material actually is very strong, and it can be used for the porous bone, and it can replace the human bone from our study. But as I said, unfortunately, we stopped at that specimen but we do not go further because there is an ethic issue that you have to get permission and so on. So that's why we don't go further. And this is the printing process. This is the one that we discovered actually from 4 parameters. This is basically a little bit detail about the process. If you go through layer thickness, infill patterns, infill density, build orientation, and distribution temperature, pressure drop, this is the one actually will affect your printing quality. At the same time, we managed to get a new nozzle using different diameter and also the diameter of the nozzle. So this one has been patented, alhamdulillah, so we can actually commercial this and then send to another company for their 3D printing and so on, can be on their 3D printing. And this is the one that has been done with Dr. Aiman. So you can see that we found out that at the end, pass parameter is build orientation and layer thickness is basically the most important factor that's going to affect the surface finish. And I'm also further up this finding by extending the research for the build orientation, not only in the on edge, but also, not only on the flat, but we eventually go for on edge to check whether it can be further improved or not. But from our finding that this checks, 60, 75, is the one that always give unreasonable condition. So meaning that you cannot print even the specimen. So from our finding, for this build orientation, 0 degree is the best one. Okay? And this is the photo from the, you can see from the photo, the structure-wise, the RA value and so on, 0 degree is the best one. And then for the 75 degree, we cannot complete our part actually. So that's from our finding. And this is the data that we get from our Tensai machine. So we can see that average force is the one, 0 degree is the best one, and others. So I would like to highlight also in terms of porosity level. So why do we need to do this study? Basically, we want to reduce the material, even though in 3D printing already less waste material. We try to reduce again by introducing, we call it porosity. So we have different design in terms of inside the part by using this honeycomb design and also grid design. Eventually, it's going to give you a best in terms of strength to weight ratio. So this is the geometry that we designed in our lab in the CAD/CAM. After that, we print, and then we get the honeycomb and grid, best in terms of high strength and also lightweight. So this was very important for aerospace industry. So we want the one that have a very good strength. At the same time, the material has to be a very lightweight. Otherwise, you're gonna pump more oil into the airplane and so on. So this infill pattern. So this infill pattern basically to make sure that, as I said before, we want to do it from biomedical or medical grade material. So this is very important. If you have a 10% yield, basically, you're going to promote more cell growth. But if you have 50% infill, then the cell growth is very difficult. So we have to find out which one is better in the bone. And next one, this is the one that I've been talking about, pressure drop. This is the one that is not been discovered before in FDM. So industry already, so-called built the machine, but they do not discover this pressure drop. So we managed to have a pressure drop. And you have a lot of pressure drop, definitely you cannot get a good quality product that you print. So this is the analysis using finite element. So you can see that for 4 PMMA, the pressure drop, you can see the convergence area is 130 degrees for the diangle with 0.2 mm nozzle diameter. So this is the result that I just showed just now. So the effect of the temperature. And this is the result about the printing speed. So if you print very fast, actually, you're going to have this problem. So you're going to have some sort of tiny hole that you can check inside the FDM. So by saying that, you can say that if you increase the speed of the printing, definitely it will give a negative effect on the FDM. And I move a little bit faster just now. I think time is not permitted anymore. Okay, the one that I'm going to show you is this one, basically, nozzle diameter. So this one we managed to pattern. At the same time, we have to control the liquefier area because the temperature is very important during the 3D printer. So we have to ensure that there is stable in terms of temperature. At the same time, when you print, and then the next filament coming into the system, so that you have to make sure that every time you can have a good temperature control inside that. And this is in terms of nozzle diameter. So different meter are gonna give you a different surface quality finish, and so at the same time, we're gonna give you a different mechanical properties as well. So from our study, the one that we recommended is that 10% to 30% of infill combined with the 50% to 70% of porosity will give you 12 to 20 megapascal in terms of load that the material can withstand. So that is very important if you want to put the bone into human body. Yeah? So this is the one that we're finding and then being published already in 2019. And this is, I compare with the slice method, this slicer method, Cura Engine and Slicer 3R. So different, the way that you slice the 3D card in terms of angle will give you a different result. So the best is for Cura Engine, whereby you cannot see any leftover material. But if you use the Slicer 3R, you're going to have a little bit so-called leftover. But I would like to state them. Slicer 3R is not always bad. It can be used for support material because support material we do not need that after we completed our product. About raster angle, the finding is 45 degrees, the best one. And yet also extend our research to drilling parameter because some of the post-processing is needed to make sure that we can get a good surface finish for the FDM technique. So according to our research, we can say that moderate feed rate and also spindle speed will give you a better quality in terms of drilling of the part. Next one, this one I think Dr. Zaleha is in the lab doing using 3D project machine. So we use this inkjet type printer. And we would like to check which one is going to give you best mechanical behavior, also strength behavior, and also roughness for the material. So we actually print out experiment and we compare with the finite element analysis. And I have a little bit more, Datuk. So this is the machine that we produce, and the machine is ready for you to see outside later on during your food time. And this is the one patented, it's number 4, very small, it's like nano size, even your eye cannot see. So that's why it's very difficult to find out the optimum parameter for this machine. And this is the pattern. And on the top of that, I would like to highlight our work with Steelcase, which actually been recognized as gold medal at IANA 2022. So Dr. Azimi was there, but eventually it's not been put inside bio because it just get it from German in October, right? Dr. Azim, October 2022. So this machine eventually, you can see the machine outside. It can be used to stabilize the nylon 6 as our Vice Chancellor. It's very important for injection molding when they inject the plastic and then we can stabilize in order to make sure that the plastic will not absorb any more moisture content from our environment. So with that, I think the plastic can be exported outside of the world. So it's not only in Malaysia and so on. Otherwise, they have to wait for 2 or 3 months to make sure that this plastic will stabilize itself. So it's going to cut about 3 months time, waiting time using this machine. The machine was set up in Steelcase Industry Penang, Gapi Industry in Penang, and then we managed to bring up back the machine to UPM. So we can see outside later on the machine. So this is the process of making the machine. It's not simple, it's very complicated because it's involved with a lot of sensors, a lot of processing conditions and so on. And next, the one we are looking for partners to commercialize. We managed to get dual cutting point. This dual because currently the machine you have a rough cutting, and then you need to do a finishing cutting. So with using this cutting tool, in Malay word we call it kata alat, cutting tool, you can only cut one time and then you can get a very good surface finish. So by doing that, you can save your time and at the same time you save your energy. So we measure cutting force and so on, but unfortunately, because of two cut at one time, the force is very hard. So we try now to coat this with a special coating using special material like titanium, carbide, and others. So the sample of the cutting tool also you can see outside, and Kamal is here, will show you the effect of this multiple coating on the cutting tool. And this is the one everybody been looking for actually. Conclusion. So I hope that I'm not taking too much time. The first conclusion, I would say that critical elements should be considered if you want to have a very good surface polish for the finished part. Eventually, you have to have also a dimensional accuracy for the part. Second one, biomedical scaffold structure was successfully being produced by using 3D printer. And we managed to fabricate consistently and also accurate scaffold folder by mentioning or getting the parameters for infill percentage, also infill pattern. And next, there should be much more research to be done in order to make sure that this printed biomedical scaffold structure can be put in human, and then you can see in terms of cell growth and also cell proliferation. And the next one, infill percentage, infill pattern will significantly affect the porosity of the scaffold. And I would say that if you change a little bit on the component of FDM, you're going to have extra features. At the same time, you can improve the product properties, and also at the same time, you can reduce the drop by using this FDM. And FDM basically can give you more tensile or also textural strength, but it's going to limit you in terms of existing drawback FDM. And the major issue with FDM is that the surface quality of the part that you produce. And this one, changing of the temperature, also nozzle diameter, we eventually will give you a good quality of the part. And machine development definitely require a major design and also issue in order for you to get a high quality, and also at the same time, people are looking at the low cost budget for 3D printer. And most defect eventually can be reduced by having this pre-processing, like we did actually using CAE and also CAE, and also post-processing as we did for drilling and so on. And next one, I think people are looking for the printing of the metal alloy. And I believe that in the now we are working very hard to make sure that we can print metal alloy by using fiber laser. We managed to get a fiber laser from Asian UC Network program under JICA. It cost us around 600,000, Vice Chancellor. So they gave us to us of charge. Alhamdulillah, in the lab now. And then two of my students, PhD, current one, new one, working on that to make sure that, inshallah, within 3 years' time, we're going to have a method 3D printing using fiber laser. Okay? The next one, I would say that FM opened a new ways that helps engineers to improve design in building complex parts in industry and also domestic use. I think before I stop, there is one video montage about 3 minutes of your time that you can see and enjoy. Okay, please. Secretariat, can you run? smart classroom been one of the one kind in Malaysia, especially together with UAE. You can see that have several equipment being donated by our partners, celebrating our Golden Jubilee for Faculty of Engineering. That's Vice Chancellor come, yeah, not me. Thank you very much for your time. Hope you enjoy my lecture series. I think there's new strategy now. I bring everything on the stage so that I can show to you what we have done in lab. Thank you very much. I pass back to Vice Chancellor.
Terima kasih Yang Berbahagia Profesor Dr. Khairul di atas pembentangan syarahan inaugural sebentar tadi. Walaupun kita berbeza bidang, adalah sedikit-sedikit yang saya agak fahamlah, insyaAllah. Dan saya nampak potensi antara 3D printing dengan biomedical science ataupun perubatan sangat luas yang boleh kita perluaskan lagi. Dan saya percaya kepakaran dan kesarjanaan Profesor Khairul terserlah pada pagi ini dengan pembentangan pembentangan inaugural sebentar tadi dan perkongsian yang telah diberikan bersama-sama dengan rakan-rakan kita sama ada di dalam dewan ini ataupun di dalam online. Okay. Jadi sebelum saya mengakhiri atau menangguhkan syarahan inaugural pada pagi ini, saya ingin bagi pihak pengurusan Universiti Putra Malaysia ingin menyampaikan satu cenderahati kepada Profesor Khairul. Saya jemput. Silakan. Mana cenderahati saya? Dengan ini saya tangguhkan masa inaugural pada pagi ini, insyaAllah. Terima kasih.
Yang hormat Datuk Profesor Dr. Mak Roslan Sulaiman, mohon untuk terus kekal di atas pentas bagi sesi penyampaian cenderahati daripada Yang Berbahagia Profesor Insinyur Muhammad Hairul Anwar Muhammad Arifin, Dekan Fakulti Juruteraan. Terima kasih ucapkan di atas pencapaian sendera hati sebentar tadi. Hadirin yang dikasihi, sebentar lagi akan berlangsung sesi perasmian UPMI Embedded System Engineering Laboratory. Untuk makluman semua, National Instrument atau ringkasannya NI adalah merupakan syarikat pengeluar Automated Test Equipment dan Virtual Instrumentation Software yang berpangkalan di Amerika Syarikat. UPM dan NI Malaysia telah memeterai Memorandum Perjanjian atau MOA pada 6 Mac 2021 untuk pelaksanaan kolaborasi dan pengajaran dan penyelidikan sehingga terbentuknya Makmal Gunasama Sistem Terbenam atau UPMNI Embedded System Engineering Laboratory yang bakal dirasmikan sebentar lagi. Makmal dilengkapi dengan pelbagai perizinan dan peralatan bernilai lebih RM370,000 yang ditaja oleh pihak N melalui projek kolaborasi yang dimeterai. Untuk memberi gambaran ringkas berkenaan makmal ini, marilah sama-sama kita saksikan video montaj yang telah disediakan. Seterusnya kita akan teruskan dengan sesi bergambar. Dijemput yang berbahagia Prof. Insinyur Dr. Muhammad Hairul Anwar Muhammad Arifin untuk mengiringi Yang Hormat Datuk Profesor Dr. Muhammad Roslan Sulaiman untuk bersama-sama ahli pengurusan UPM dan juga ahli pengurusan Fakulti Kejuruteraan untuk naik ke atas pentas bagi sesi bergambar. Sebelum sesi bergambar di atas pentas, kita akan bergambar bersama hadirin di dalam auditorium ini. Dijemput semua hadirin untuk berdiri dan sesi bergambar bersama-sama. Dijemput hadirin untuk berdiri untuk mengambil gambar bersama-sama dengan ahli pengurusan universiti dan juga ahli pengurusan fakulti. Terima kasih. Hadirin mohon untuk terus kekal di dalam auditorium ini. Terima kasih. Hadirin dijemput duduk. Hadirin sekalian, majlis akan diteruskan lagi dengan sesi lawatan ke UPMNI Embedded System Engineering Laboratory. Majlis menjemput Yang Hormat Datuk Profesor Dr. Muhammad Roslan Sulaiman, Naib Chancellor Universiti Putra Malaysia, dan Yang Berusaha Encik Selva Pencinapan Pengarah Urusan NI Malaysia, diiringi oleh Ahli Pengurusan Universiti, Ahli Pengurusan Fakulti Juruteraan untuk sesi lawatan dan terusnya menyempurnakan perasmian UPMNI Embedded System Engineering Laboratory. Saya mewakili jawatan kuasa penganjur memohon maaf atas sebarang kekurangan sepanjang majlis ini berlangsung. Kambing golek sudah menanti, hidangan istimewa buat semua. Sopan santun jangan berlari, jemput semua jamu selera. Tetamu jemputan dijemput untuk menikmati jamuan makan di pekarangan foyer Fakulti Kejuruteraan. Sekian sahaja majlis syarahan inaugural pada hari ini. Saya sudahi dengan lafaz wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Sekian, terima kasih.